Here in this video, we will learn about circular linked list. But before going to this circular linked list and its algorithm, we will revise the concept of the linear linked list. When we say linked list, this means linear linked list, and we will revise the linear linked list first. Thereafter we will go for this circular linked list, and in this video we will see only the algorithm. So I start, and in linear linked list, nodes are created with the help of malloc function. And remember, all the nodes are not created at the same time. Nodes are created one by one. First node is created, thereafter the second node is created, and so on. And before creating the next node, we attach the nodes which are already created. So according to this linear linked list, you see, suppose we create a node. So far you have seen so many programs, and a node contains two parts. The first part contain a data part. Here we have the data part, and here is the next part. This next is the link, and precisely if I write according to the program, then this will be star next. Okay, so this is the first node, and this node is created by the malloc function, and thereafter we enter a value inside this data part. Suppose that value is 1. So data 1, accordingly name the value entered here in this data 1, and this next part is made equal to null. It is essential. If you want to attach the next node, then it is necessary to keep this next part equals to null. So when we create, then suppose the name of this node, suppose the name of this node is temp, and always remember, in all programs, the newly created node, I think I don't remember that in all program, but I can say that in most of the programs, the newly created node is named as temp. And what does this node mean? Though the node means this whole part. This sorry, this you see, this whole thing is the node, and this is named as temp. And after the creation, this part, in this part a value is inserted, and in programs I have inserted a data, an integer data, and that according to that the C program, the C statement is written as, here the node name is temp, so I type here temp. Thereafter I here I take an arrow, because this temp there has been declared as a struct node star temp. For that I take here arrow, and this thing means the data inside the temp, and thereafter this is assigned as, if you have declared the variable as element, then here we type element. It depends upon what you have taken as the variable, and in most of the programs I have taken this variable to be element. And thereafter you see there is second part as well. Here you see the second part, this part, and this part is written as, in this part null is set, and to set we type the C statement, and here you see there is always a semicolon to terminate the C statement, and here in the same way we type temp, and here next, and it is read as the link next part in the temp is assigned null. When we write in such a way, then we say that the two parts have been assigned. The two parts of this node temp has been assigned. Thereafter we create a second node. But one more thing before that, before creating the second node, we we assign two variables. We take two variables. First is the first variable is the first. Suppose it is first. Somewhere you can see star first according to the variable taken, but I take here first. First is assigned this value temp, which you created newly, temp. Here I type with the help of my finger, so my writing is not good. And we at the same time take the second variable whose name is move. Here you see move, okay, and this variable move is also assigned the temp. So both here in the, when we have the first node in the linked list, both first and move have the same thing, and that thing is temp. Okay, and after this, after assignment, we assign the variable first temp, the variable move temp, and thereafter we create a new node. And when, and to create a new node, we again use the malloc function, and when malloc function runs, it gives a, a node, this node, suppose, and as usual this node as well, this node contains two parts, and this node is also named temp. and the user may get confused. He may ask that name of the first node is temp, name of the second node is temp. This is a problem, but you should remember this is not a problem. This is a benefit. This is the benefit with which the we use creation. We use the iterative process. More precisely, I say iterative process is based on these things. And if in a C program you see two things with same name, then updated is taken. And temp, you see temp thing here, here you see temp thing, and you see the same, but as I said, in C updated is taken. This means that temp is now the second node, not the first node. Remember that. And here again we have inside these two parts. The first part is the data part. First part is the data part, and second part is the link part, which type I took in the programs as next. This is the link part. And again for this second node we write the same. That is, we write this C program, and we type the second thing, that is this thing, for the link part. Then when you type these two things, then we say that we have filled two parts of the second node. And to differentiate this node from the first node, I take here data 2. Suppose data 2 has been inserted into that data part, and again this next part is made to null according to this C program, you see. And after that this these two nodes are attached. How can we attach? Attaching is done keeping this data part over this next part. To attach, we take the next part of the previous node and data part of this present node, and we keep the data part of the new node over the link part of the previous node. That is we keep this part, you see this part, we keep this part over this part. And if you do so, then the resulting structure will be like this. I show you. This will be the resulting structure. Here will be three parts now, because if you paste one part onto the other, then one part will be obviously eliminated. So here will be data 1, here will be data 1, here data 2 comes, and remember, notice the link part of the first node is below the data 2. So link part of data 1, link part of the first node is not here, and this next, here will be the next, and this next is of the second node. Remember this thing as well. And this is the link part, and here if we write precisely, then in the third box there will be null. Okay. In this way you see that the two nodes get attached, and in the same way you can attach many data after that you take third node, then obviously there will be data 1, data 2, data 3, and next. But here there is one question. Here I have attached, but the viewer may ask, the viewers may think that what is the C statement for this attachment? What will be the C statement to attach in this way? The C statement will be, I show you. Here you see the next part of, I mark it with the green. You see this. You see under the green line, under the thick green line. So this part is taken to attach, and the second thing is taken. Second is taken this part. Okay. So the C statement is written accordingly. C statement will be, here you see, move. Move is the first node, because when I take temp for the first time it was the first node. So this move is the first node. So here the C statement to attach will be move. Remember, move. Here I type move, and thereafter move is the first node. Move, and the link, we take the link, and the link part is next. So I type here next. I typed, and thereafter this next part, over this next part we take data 2, that second thing under the thick green line, data 2. So if you write this statement, if you take the statement like this, then this is the C statement to attach. If you do so, then you have the structure like this. You have the structure like this. And in the same way, if you repeat the process, if you repeat the process, then if you repeat the process, then you take, obviously you will take the next node, and after repeating the process you will have the a structure like this. I show you like this, like this. For the next time you will have the structure like this. In the first there will be data 1, data 1. In the second there will be data 2, and in the third there will be data data 3 3, and in the last, always in the last there will be a link part, and you know that link part is written in the program as next. Okay, so this time you see 3 data. You can increase the size of this linked list. Here the size of the linked list is 3. You can, if you repeat the same process again and again, then the linked list will be larger. And this is the structure of a linear linked list. Okay, so to attach to attach we use the link part of the previous node. We take the we take the link part of the previous node and the data part of the newly created node. And here you see the linear structure. Before that, one thing I have not written here. Before going to the third node, you have to use one more C statement. You know, uh, when I created the second node, its name was temp. So before going to third node, you have to write one more C statement, that is move equals to temp. If you write in this way, then the move will indicate the second node, because the temp at the creation of second node was the second node. So if you type the C statement before creating the third node, it is necessary, then move will indicate the second node, and thereafter we create a third node attached. So we have this structure, the linked list of size 3, and after that, after this attachment, we again type the same thing, equals to move equals to temp. If you do so, then if you write this thing again, then this time you know the move will denote the third node. So move, the variable move always indicate the last node. So in this way you can get linked list of many size, repeating the same process. Now we go for the circular linked list. And to understand circular linked list, there is a conceptual question whose answer is essential. And the question is, here you see, first see the structure. You see a linked list of size 3 on the screen. And my question is, can you attach? I have so far attached 2 times. First I attached data 2 with the data 1, thereafter data 3 with the data 2. So I have attached 2 times, but these 2 attachments become possible only when I created the second and third node. And the question is, can you attach one more time without creating a new node? If you seek answer of this question, right answer, then you can understand the concept of circular linked list. And still If you have not understood, then I am giving you a clue by drawing a structure. The structure for the same linked list. We have the linked list of size 3. So I am showing you a structure. Here the structure is like this. A structure is like this. Like this. And here I make 4 parts because in the upper structure there are 4 compartments. Accordingly, I take here data 1, data 1. Here I take data 2. Here I take data. My writing is not good because I am using my finger, not a pen. I have pen, but here currently is not in my position, and here will be next. Okay, and I say that both the structures are linear structure because line does not mean a straight line always. Line may be a curve. So both are lines, but there is a difference. The first structure is of linear structure and the second is a curve, but I can say that both the structures are linear structures. So in this context both are same. But the second structure, if you see the second structure carefully, then you can answer my question. I repeat my question. Question is, can you attach one more time without creating a new node? The answer will be yes. I can do. We can do. How can we do? Remember the concept of attachment. To attach, we need two things. First one is the data part, and the second thing is the next part, that is link part. And you see here, if you take this data part, if you keep that data part onto this link part, then obviously there will be an attachment and resulting structure. If you do so, then the resulting structure will be like this, like this, like this, like this. Now there will be sorry, like this. You see? Okay. And here will be the data one. Data one will be over the link part. Here it has gone outside, but you understand, this will not go outside. And here will be data 2. Here will be data 2, data 2. And in the third will be obviously data 3. And now you can see that this is a circular linked list, data 3. This is a circular linked list, and this is the algorithm of, or you may say this is the algorithm to get a circular linked list. and in the next video we will see, we will write a program to get a circular linked list. Okay, thanks.